Alrighty, happy Monday. Hope you're staying dry. I have an umbrella in my car and I didn't grab it. And I walked in the rain because I was actually running late to my first class because I had a doctor's appointment this morning. You think a 9 a.m. doctor's appointment would be fine to get here for 11, and it was not. I should know better. Um, I have an eye doctor appointment tomorrow morning too. So all sorts of fun. Project Zero, due Wednesday before class starts. The first thing we'll do Wednesday is I'll go over the solution to the project. So I'll show you how I would solve it. Doesn't have to be the way you solve it. That's okay. 7 different ways to do anything here. It's just one approach. And then we'll talk about our next project as well here. I don't think we're going to get very far into new content. Um, so we're going to finish up loops today. Maybe we were able to start loops a little bit early last week, so we can finish up loop content today. We'll do our lab on loops, and then we can do the solution to Project Zero, talk about Project One. That should be a pretty good day then for Wednesday. Okay, should be good, and then we can get back on the Monday, Wednesday schedule here with functions. I think that should be pretty good. Unless we have tons of time, we can start. I don't think we'll even need to start functions. So it should be good. So might be a little shorter on Wednesday. Um, that'll get us back on track here for this. Um, yeah, awesome. Let me fire up PyCharm. I know, yeah, PyCharm. So I did install the new one finally. Why is it not showing on my list here? I didn't know I installed the new one for Java. I told you I'm really tired. Um, I should install the new one for PyCharm too. Um, sorry? uh, the internet is pretty quick. It's a pretty quick download, but I think the install is ever so slightly slow. Um, I'll do it in lab. I can do it during lab right after this. That'll work here. All right, so we've got our loops we've went over so far. Did a couple different things with loops, right? Lots of different loops within loops here. We did for loops, we did while loops. Right? For loops for some fixed number of times, or for every item in a collection, which also happens to be a fixed number of times here, which is nice. We're able to do that. Now, other times when we might want loops here, uh, before we get into some of those advanced loop keywords here that I dislike, um, other times while loops can be really useful here is we're doing something that we don't know how many times it's going to take. Right? So we need to let them keep on entering value. So if we were to say, hey, let's like total up the receipts in your register and see how much money should be in your register. I did, there might be a button somewhere that tells you how many receipts are in there, but we'll pretend like there's not. Uh, as you can quickly tell, I've never worked a retail job in my life. I'm a bit spoiled. My apologies. So we'll ask them. So maybe we'll have an int for a total here, starts off at 0, and then we'll ask them to enter a receipt, right? Or like some invalid number. We call those a sentinel value. What number means something special? So I don't have to say enter a number and then yes, do you have more? Yes or no. Enter a number. Yes, do you have more? Yes or no. Enter. That like gets really tedious really quickly when I can say enter a number or like -1 to stop because you probably don't have a receipt in your drawer for -$1. Right? You're not customer service, so you probably aren't giving money away. But if you do, you'd be in big trouble, I'm sure. Oh, that sounds awful. A fun fact here. Actually, it's not even a fun fact. It's more of a sad story. But in technology, it tends to be hey, when people make mistakes, it's only a mistake if they don't learn from it. We're like, oh, it's okay, you did a bad thing here. You cost us $15,000 because you crashed the server, but you learned your lesson, right? And they're okay. And our poor retail workers, your drawer was 37 cents short that's coming out of your paycheck. I don't know why the world works the way that it does here. But we're going to total our receipt drawer here. So we can ask them here. So we'll get a receipt, then we'll equal in probably a float of an input here because we're dealing with some pennies here, right? So enter a receipt value or -1, stop. And then we can loop. We can say while my receipt does not equal -1, let's keep on going. I'm going to add that receipt to the total. So total plus equals the receipt. And then I'm just going to prompt them again. If they enter a -1, the loop stops. The -1 never gets added to my total. That's an important step here. If the sentinel value is a weird value, make sure we're not adding it to this running total here. Right? So eventually we'll get a total of all the receipts here because I don't need to say enter receipt, do you have more, yes or no? Enter receipt, do you have more, yes or no? That's okay, it's just obnoxious. I know I don't want to use a system like that here, so I'm going to write it differently here. Now, if -1 is a valid value for a receipt, fine, then change it. Be like, hey, how about -999, right? Or some ridiculous number here, right? Something that is a floating point number here and that is invalid, right? Probably makes sense. So whatever number makes sense here is okay for you to use as your sentinel value. These are sentinel values, unusual, invalid values to stop a loop. Right? And that's just a whole lot easier. Uh, or if I were to like build a list of students for my gradebook, enter a student name or quit, because I've never met a student named Quit. I don't think any parent is that cruel here to name their kid Quit. Right? So that's probably a decent sentinel value here. Right? So I can say, here's my gradebook is a dictionary, and I get a name is an input. Enter student name or quit to stop. And while name does not equal quit. Now, maybe uppercase it here, right? Dot upper, but you might not want the names uppercased. So name dot upper, like if we name dot upper here, remember it doesn't change the name. It only changes it while we're looking at the comparison to quit. So depending on where you want to put that uppers, fine here. So I can take my gradebook key of the name here then, and with associated value, I'll start with 100, right? Until we know otherwise, or maybe 0. I don't know. Sure. Well, whatever the gradebook happens to be here, and then we just ask them again, right? So again, this is another sentinel value to stop the loop. Okay, whatever it happens to be. So it doesn't have to be numeric values. It could be string values. Whatever we're doing, these loops can be useful because I want my program to do something for you until you decide you're done with it here. And that way the program can vary based on different users. I have 10 people in this class. I have 22 people in the morning class, right? I have different numbers of students in my gradebook. And then you don't even have to ask them, how many students do you have? And not enter that many. You could, right? That could work too, right? We could have a number of students, right? Is an int of an input. How many students in your class? Right? And then we could say for, I don't know, student in range number of students, right? Because we can range over from 0 up to that number here, right? And we can get a name as an input. Just, I don't know, student number. And we can do this as a little formatted string here. Number, student number one's name. Sure, whatever. And then we can take my gradebook key of that name, right, and assign them 0. Or we can ask for this, whatever we wanted to do, right? Something. I guess we should ask them a score, right? After score is int of an input. Do you do double? Do you do decimal places in your scores? Might make sense to do a float here. We'll do a float just in case, right? Float of an input, score for, and do that as a formatted string for the name. Right, and we'll do that again here for the name, and then we can assign the value of the score. Great. So in both ways work. This is just a style preference here. How do you like to do your loops? So sentinel values are nice for that sort of thing. Now, with receipts, you probably don't want to have to go count them all, that sort of thing. So there's some cases we might just not know how many we have. You just keep on flipping through here. We're good to go. Got lots of fun options there. So we pull up the Zybooks here. Make sure you got the right one. You don't want C++, that's gross. Here we go. Counting loops with ranges, for and while, nested loops, programming incrementally. Right, we're going to build out little bits at a time. This is my favorite way to program. That's ideally what I've been doing. And as we look at the projects, I'll show you, we'll do little bits at a time. Break and continue are my least favorite words in Python here because they confuse me. Perfectly valid. Some people really love them here. I despise them just because they confuse me really easily or really quickly here. So what you can do with the break and continue here is break will stop the loop. It just hard quit ends the loop here. So you could make a loop like this. We could say, hey, let's do the same idea here. Let's repeat here. And then some people do this awful thing and they say while true here. And then if receipt is equal to -1, break. So we don't need to do this one here. I don't know. Then we could add it if we don't break. Okay, this is sure we've saved like 2 lines of code. So we'll ask them for a value. If it's my some value, that means stop here. Break means stop the loop. Hard stop of the loop. Do not pass go. Do not continue. Continue. I can't spell continue. Right. So as soon as it hits a break, the loop is done, no, regardless of the condition. So right now it looks like it's an infinite loop, right? While true is never not true. We've broken the rule of loops: is don't do infinite loops. You make people sad. Yeah.
Does it restart the loop or does it just go back?
And it completely goes to the end of the loop, keeps on going here. So print is the line after the loop here. So break will jump to line 13. Right? Just stops the loop, goes on, finds the next thing after the loop, and continues on from there. Right? I don't like it because it interrupts the flow of how I read code. I read code from top to bottom, right? And if it's a loop, I'm like, okay, top to bottom, go back to the top. Top to bottom, go back to the top. Right? You can put breaks anywhere you want here. It's just visually jarring to me here. And I think this is perfectly fine to have a while this is not here. Right? It's a style preference here. So I will never use breaks because they irritate me. I dislike them. But it just stops your loop here. So you can do fun things with them. Quickly bail out is what most people do with their loops. And then other things we can do with loops here are continues. So we could say for number in range, let's go to 100 here, right? And what we want to do is we want to print all the numbers that are even, print all the even numbers. So we can say if my number modulus 2. Now, this looks ridiculous here, but remember, I think we mentioned here briefly when we were talking about these Boolean conditions that Python is truthy. Everything in Python is true or false, right? So numbers are true except for 0. Any number other than 0 is true. So if number mod 2 is true if it's 1, if it's 0, it's false. So this is the shortcut. So instead of saying if number mod 2 equals 1, I just leave that off here because if it's 1, it is true, and I can leave that off here. So shortcut for if number mod 2 equals 1, right? Because 1 is true. Right? Anything not 0 is true in Python. So people do this all the time, and it drives me a little bit crazy. I've gotten used to it after doing it for many years here. So um, I do it occasionally. Sure. So you just yell at me if you don't like it. So if it's 1, right? So if it's odd, we're going to continue. And continue says jump back to the loop header. Go back to here. Either the next one or the next while test. So you can use it in while loops or for loops. Same with break. You can use it in while loops or for loops here. It just goes to the next value. Or we'll go check is your condition true again as we go here. And then if that didn't happen, then I can print number. So this will print all the even numbers from 0 to 99, right? Because we don't get to 100 when we range to 100 here. All right, so enter receipt value. I'll just do -1 to stop, and we get all the even numbers. 2, 4, 6, 8. Who do we appreciate? Sure. 0. We could start it if we wanted to not start at 0. You can start at 1, right? Um, bless you. Now, you don't have to go through all this work to do this here. Turns out range is really smart and fancy, and range knows how to count by numbers. So we could say for even number in range, I can say, hey, I want to start at 2. I want to go to 100, which really stops at 99. And what do we want to count by? I want to count by 2s. You give it a third number here. It's the count by value. Bless you. Right? I don't know. Third thing is a count by value. Does that make sense? Is what I'm saying? Count by. They call it a step. Is the technical term for it here? You step by 2. Sure. So this now just prints the even numbers here without any extra work of having to check if it's even or odd, right? This works out really nice.
Step and like have equation stuff be the step.
Um, don't know if you can use equations.
Like parallel, but I wasn't sure that you could do like have a formula be the step or something like that.
I don't think you can. I don't know. I've never tried. You can do.
Not sure when you would need that, but I can imagine maybe scenarios where like you'd want a formula figuring out what the step was or
I think it has to be just an integer. I don't know that for sure. Difference between each number. I think, yeah, I think it just is an integer difference here. Um, Other than that, you would just use a loop and do that interesting thing, right? Instead of a for loop, just use a while loop or something. This will get you even numbers. So because we can step, we can also do silly things like here's a count down in range. You can start at 10 and go to 0, but it's not including 0, so really we want -1. And to count backwards, you tell it the step is -1. And I will get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then we can print blast off, right? So yeah, -1 to stop. Here's our countdown, right? Or here's our counting up, right, by twos with the ranging here, and here's our countdown. We get our blast off here. So you can decrease in a range if you tell it the step. Now, 10 to 1 without the step here, you get nothing. And Python's like, oh, from 10 to -1, you're done. There was nowhere to go, right? Nothing happens. So you have to have the step here if you want to count backwards. Just by having a greater and smaller number, it's not smart enough to figure it out itself, right? Because it's like, oh, don't add 1 until we get to here, because 1's the default. It always tries to go up by 1. So you can do fun things with ranges here, which is cool. Um, our loops, there we go, break and continue. The other weird thing you can do, I've never seen this anywhere other than Python, is you can add an else to the end of a loop. I don't recommend this just because I find it confusing as well here. So if the loop doesn't break when it's no longer true, the else will run. Right, so it's essentially pretending like it's an if block here. So we can say, oops, I didn't want to move those down because I want line 13 to still be here. Otherwise, again, this is why comments are stupid, because it really quickly, as I move code around, no longer is true. And when I say line 13, and I've put all these down a bunch of lines, it doesn't mean anything anymore. Um, all right, I'll put it over here, I guess. Ah, that's ugly. Here's our while loop here. So a while receipt is -1, I can put an else here, and then print, thanks for totaling your drawer. If you lost any money, for taking it from your paycheck. All right. This else will run if a break doesn't happen. So when the loop is done, like if it's essentially like pretending this is an if. So if this, when it's no longer true, then else runs. Because break says go to where the loop is done, it never has a chance to look for an else because it looks for where the loop is done, right? And else is sort of attached to it is all. So again, I never use these because I find them obnoxious. But you can do lots of fun things with them here. Uh, see, do we cover all of it? Oh, and then enumerate. This is a really good one here. So enumerate is fantastic. So when we looked at using loops, we said essentially it is read only when we use the for loop, right? We did one of those. Where is it? For loop, right? If we do a for loop, it's essentially read only because we're getting a copy of it here, right? So if you go over the index, though, you can actually change the value that's stored at that index. Does that ring a bell? I know it was last week here. It's a couple days ago. It's all right. So basic for loops, we get a copy. By index, you can actually go and change what's at that index. Right? So changing something from the for loop doesn't change it inside the list. So the only time you can change what's inside the list is when you tell it, hey, change what's inside the list. So I like to remember that. So a shortcut here then, if we're doing these sorts of things, you don't have to go back and get the index again here. then is using enumerate. So enumerate gives you the index and the value here in 2 and 1. Now it looks crazy though. We're going to say for index comma value in enumerate the alphabet. Enumerate or no, enumerate. Enumerate the alphabet. So I'm asking for two things because I know enumerate gives me two things. Right? Create returns a new object of the two things here. That was not very helpful. That was not a good helper documentation here. No. All right, that was ugly. But I can do the same thing then. So alphabet of index then equals the value dot upper. And look, I saved a little bit of typing. I don't have to say get the thing back from this index because I already have it here as the value. And then I'm saying store it back in here. So just a little bit faster here if you want both the index and the value back out here. And you don't necessarily have to change it either. You might say, hey, let's make a list of what we have here. I think we had a list in here, didn't we? We have another list? Didn't have another list. How about we have like a list of students here? So we'll have a students list. We'll have Eric, Jeb, Vivi, Journey. Right, so then I could say for, I don't know, ID, it doesn't have to be the word index. I usually use the word index because that's what it represents here, but we can call it ID and name in enumerate of students. Print, oh, we shouldn't use ID here. We'll say number, sorry. Uh, remember there's the ID function that shows you what is the memory address essentially of an item here. So you use a variable named ID, it gets really confused. It's like, oh, we already had this thing called ID. So we'll print as a formatted string here, student number, or colon, right? So I can just get those values out here pretty, oh goodness gracious. 1, -1. All right, receipt value, -1. All right, student name, we'll just say quits. Students in class 1. Eric, score for Eric, 100. I don't even know where I am here now. Where do we, did, it did it at the top here, guys. It happened too fast. I wasn't looking. So, hey, student number 0, Eric. Student ID 1, Jeb. 2, Vivi. 3, Journey. So you can get them back out quickly this way here. So you don't have to be changing them is all. So if you want both values, it's a quick little shortcut rather than here's the index and here's the list at the index to get the value back out here. So just a shortcut is all we do with enumerate. All right. Dice statistics is one of my favorite things here. I love dice. So this is figuring out how random something actually is, right? So it calculates the number of times the sum of 2, and these are 6-sided dice here. Dice do come in different sizes, in case you weren't sure about that. 6-sided is just a common die that we typically use here. Apparently, you have to say dice because YouTube and other social media platforms get upset if you use the DIE word, and you're likely to get filtered out. So people who play tabletop role-playing games and put their games online for nerds like me to watch always refer to individual ones of them as dice, and it drives me nuts. Um, but it's to satisfy the social media stuff here. So, um, sure, dice. We can roll 1 dice. It hurts. It hurts real bad. But 2 6-sided dice here. So pick a random number. Pick another random number. Add them together. Right? If it's a 6 or if it's a 7, here, count how many times we got a 6 and a 7. Right? So we could count all of our numbers here, right? We should get a nice looking distribution. You guys are pretty good at stats at this point, I would hope. Probability and statistics. By the time you got to calculus? Did you not take a probability and statistics class? Really?
I did.
Okay. You'll take the engineering based statistics course, which best I can tell is statistics with calculus. So instead of having your table for p-values, you like calculate them yourself because that's interesting. I never took it, thankfully. So I took the regular stats class, which was a lot of fun because I like numbers and statistics. And there are certain people in our government who need to understand what a p-value is, and they don't know what it is. So when you hear a press conference today at 4 o'clock, about a bunch of crap. Just ask yourself if you know what a p-value is. Um, okay, I'm sorry. I'm tired and cranky. Anyway, so we can count. So I'm just going to steal their code because this is fine. Um, and put this up here. It's not going to be line 13. Jump to the end of the loop. Next line after. Right, we'll put it at the top here. This is, we get it from here. I'll even put a little note in here, right? Because this is what we do when we take people's code. We leave a note. I've cited my source here. Now, I want to count more than just sixes and sevens, right? Right, so I want my num, my number of, is it hard to type that? Sure. Number of twos, right? Threes, fours, fives, sixes, sevens, eights, nines, tens, 11s, 12s, right? Great. Threes, fours, fives, sixes, sevens, eights, nines, tens, 11s, 11sies, 12s. Sure. And each of these is zero. I'm just copying and pasting there. Okay, that should make that a little happier now. Okay. How many times should we roll? Sure, this will be fun. So in the range number of rolls, now as long as it's greater than one, if it's not, does range die if we range negative? It might. I don't think we can we range negative? I'm really curious now. Can we print range negative 10? What happens if we range negative 10? Huh. 0 for value in range negative 10. Print the value. Print the value. Nothing happens. Seems like a useless if. That's really weird the book would have that in there. I'm going to take it out. Seems like a not use it well worth our time here. Invalid number of rolls, try again. Oh, yeah, no thanks. All right, roll 2 dice, sum them up. If the roll is 6, add to my number of sixes, add to my number of sevens. Goodness, this is kind of tedious now, isn't it? And really, these should be elifs here. Come on, look, I'm disappointed. I'm going to write them a strongly worded letter. If my roll total is equal to 2, take my number of twos plus equals 1, right? Save yourself some typing here. Right? They did all sorts of things here that I was, wow. Elif, my roll total is 3. Are you thinking to yourself there's a better way to do this? That's what I'm thinking. No? Okay, I'll just keep doing it this way then. What? Promise you there's a better way. Even copying and pasting here is awful, but that's okay. What? Look, how do we know which is the right one of these to update though? It's the small problem here, right? For because I've got a variable called fours here. Wouldn't it be nice if like I had some way to have a bunch of values in a collection and reference them by number? You could use a dictionary, sure. Dictionaries are great for stuff like that. You could also just use a list here. I'm partial to lists. A dictionary might be a little nicer, maybe. But lists work out really nicely too. With lists, we have to do a little bit of extra work and just pretend numbers aren't there. I think is why lists are a little sad. So yeah, let's not do this nonsense here because that's dumb. Okay, it's not dumb. It works. It's inefficient and slow, and we can do better because we're lazy, right? Like any good programmer, I'm lazy. I don't want to do more work than I need to, right? And I've learned a couple things like dictionaries, right? We can do a dictionary. All right, let's do that. So we'll have a dictionary then here. Here's my uh, what roll counts. Here's a dictionary. And then for now, I want the numbers 2 to 12, right? So for number in range, if I want 2 to 12, I need to go from 2 to 13 here. I'm going to take my roll counts, key of the number, associate a value of 0. Until I've rolled, it's been rolled no times, right? Okay. How many rolls am I going to do? Get my roll total. Now, all I have to do, I don't actually want this line in here either. I can take my roll totals here, key of the roll total, roll, nope, roll counts here, sorry, roll counts, key of the roll total. I can't say the word roll anymore. Like, it's lost all meaning. And what do I want to do with the value associated with this one here? I want to add 1 to it, right? So we'll equals 1. Take the value here, add 1 to it, assign it back. And we're done. We print a dictionary. Print my roll counts here. Let's give it a try. How many times should you roll 2 6-sided dice? 25 times here. So we got 2 one time, 3 no times, 4 one time. 5. This output is ugly. Can we do better? I'm glad you asked. Man, you guys are you're on fire today. Yeah, let's make it look better here. So, what if we say for I don't know what roll counts? Now, remember when you use a for loop in a dictionary, you get the keys out, right? You still have to go to the dictionary key of this to get the associated value out. That's fine, right? So we could say print as a formatted string the roll and then colon space and then the roll counts key of the roll, right? I'm sorry? Yeah, and we get new lines right away, right? So 25, no, not the debugger. That one's too slow. 25 times, right? Oh, we got more 6s than 7s. It's random, right? But again, we see a lot of them here. Let's go more than 25, right? Let's do like 100. We should get a better distribution here, right? This looks like a pretty normal distribution now, right? Again, it's numbers though, and I get a little confused. Can we do better? Yeah. So instead of that, let's take that divided by our number of rolls. Give me a percentage. Right? Can we do that? So take that divided by the number of rolls. Num roll. Why num number of rolls? Don't be lazy. Come on, textbook. Right. So now we'll get a percentage back out here. So I could roll, say, 1,000 times here, and I get my percentages. Now that looks a little ugly. Okay, we can make it look better. Thanks for asking. Yep. So we'll take all of that, then times 100, right? And then we can use our little formatting string here, right? I don't want this as a decimal place here, or maybe like what, 1 decimal place, 0.1f here. Sure, we can do that. Throw that in. My number of rolls, then we can do 1,000 rolls. These are percentages here. Well, maybe we should add the percent sign. That's the percent sign here. And we can make our output look prettier. So if I do like 10 rolls here, really wacky looking distribution, right? But if we do 100 rolls, it's a little better, right? 13% at 7, 18%. Okay, still more at 6. Interesting. So let's do even more rolls here. That was 100. Let's try 1,000. Now we're getting a little better results here, right? We're narrowing in on 7 being the most likely outcome here, right? 1/6 of our rolls, right? Is that about 1/6? What's 1 divided by 6? It's pretty close. Not exactly there, though, right? We're at 15.7. So let's do more, right? Let's do even more random rolls. Let's do 100,000. Now we get 16.5. Look at that. We're pretty close here, right? To the 16.66666. Likely random. If we want to do a million rolls, probably get even closer, right? As we went. That's not too bad for an output. Now, all of these things here are variable. It could be variable, right? We had to hard code a couple things right now, right? We hard coded the start, the end here. It's not the end of the world. We only have 2 dice that we're rolling here. What if we wanted to do the distribution of 3 dice? We'd have to change a bunch of code. And that's sad, right? Because we could do better. Glad you asked. We can do better. Yeah. So instead of having them coded in here, let's ask how many dice, right? How many dice is an int of an input? How many dice do you want to roll? Right? And then instead of it being here's die 1, die 2, die 3, right? We'll say and then this is the number of rolls of this many dice, right? Uh, for roll in how many dice, or no, die in how many dice? Dice in how many dice? There we go. How many dice? Again, or range. I'm sorry, range of how many dice? There you go. You got a range over that. I don't care about the value of dice, right? We're going to throw it away. You could use the underscore here, but again, I'd like the meaning here. We're going to have a roll total starting at 0 and take that roll total and add to it a random number, right? For how many dice you want. When we're done, we have counted that roll total, right? And then we do it again. We do it again. We do it again. We do it again. Now, but my dictionary is off here, right? Because if I have 3 dice, my sums are going to be different, right? So I need the sums starting at how many dice here, right? 3, right? And then the how many dice times 6 plus 1 to make sure I'm above the max, so I stop at the max here. Otherwise, we're going to get key errors really quickly with our dictionary because you can't add to something that doesn't exist. It'll get upset with us. So now I should be able to say, okay, how many dice do you want to roll? Let's try 3. How many rolls should we do? Let's do 1,000 rolls here. And now I give a distribution here. Most likely now I'm getting at what 10 and 11, right? 7 plus 3.5 should be 10.5. Somewhere between 10 and 11, I think, is my most likely outcome here. Looks pretty close here, right? Very few threes, very few 18s. That's what we'd expect, right? A pretty good distribution here. And I got all my values, right? Does it work with 1? Can I roll 1 die 100 times? Should be pretty even with 1 die, right? That's probably pretty close. Again, we could do tens of thousands of them if we wanted, those sorts of things here. Um, but this is sad. It only works with 6-sided dice. All the other dice are feeling left out, especially the 12-sided die. No one uses the 12-sided die. That's a fun one here. So we can ask them, how many sides are on your dice? Right? How many sides? Is an int of an input. How many sides are on your dice? Here. So then my how many dice, it's not times 6, it's times how many sides here. And my random number is 1 to how many sides. Right? Everything else is the same. Right? So now I can roll. Let's do 12-sided dice here, and let's roll 4 of them. So we should have 4 to 48, right? The middle number on there should be what is that? 6.5, 6.5. So 6.5 times 4 ought to put us at 20, 26. So 26 should be about the middle here, right? If we do 1,000 rolls. 26 got 6% of the rolls, 6.5%, 25. Okay, pretty close. No percent of the rolls were 4 here, and we're rounding, right? So if we didn't round so far, we might have had a few percent, like very small amounts, but 1,000 rolls with 48. I mean, I feel like we should have hit a couple of them, but because we're rounding again, it's a little bit awful. So let's go like 0.3, get 3 decimal places. So 12-sided dice, 4 dice here, and let's do 100,000 times here. Now we see, okay, occasionally we get those really rare looking ones here, right? Although we would have lost it in the rounding with just a single decimal place, right? We would have said, oh, that's not possible here. How's that? Is that fun? Y'all like dice? I like dice. Um, so I think now we can figure out what chance we have of rolling any combination of dice here, right? That worked? Okay. Um, now, other silly things you can do in tabletop role-playing games, such as Dungeons and Dragons, uh, are you get to roll 2 dice, and sometimes you have advantage, which means you get to take the better number when you roll twice, and sometimes you have disadvantage, which means you get to take the lower number when you roll twice. And you can see how that affects your outcomes of rolling 2 dice. Right? What is the average roll if you roll 2 dice with advantage? What's the average roll if you roll 2 dice with disadvantage? Here, and usually those are the 20-sided dice. Right? Those are going to be fun. So we got to roll twice and see which number is better, and figure out the average of that. Right? You can do the math here, but this is why I like Python, because I don't have to do the math here. I can write some Python code that rolls 2 dice, checks which number's higher, and logs it. and then do that a million times and be like, I'm pretty sure that's really close to the answer you would calculate if you knew the math. I don't know how to do the math for that. I'm sure we could look it up here, right? I think there's a video. Um, I think, oh, is it? I think Stand Up Maths is the guy who did that one. Uh, Pretty sure. Stand Up Maths, rolling two dice, any higher number. I think that's what it was. Yes, he even had a so the unexpected logic behind rolling multiple dice, picking the highest. I would play his video, but then mine will get muted because I post these on YouTube as well. So we can watch his video. We'll do this for lab here. We'll write some Python code ourselves. Because he writes Python code. And he always laughs about how terrible his Python code is because he's a math major, which is fine. That's okay. You don't have to be a good coder as a math major, but he likes Python, and it just makes me like him even more. So um, we'll do that for lab. That sound fun? It does not sound fun. It's okay. Let's admit it does not sound fun. um, yeah. So I'll play this. This is a 27-minute video. We could watch this until 1:45 and then go to lab at 2 here. Does that sound good? All right. So I'll post the link later or go find it here. We'll watch it in class and I'll stop recording for what I post to YouTube. And then we'll go write our own Python code for this. It'll be a lot of fun. Okay? Awesome.